Hi, I'm Duncan Bearding. I'm in the Duncan Bearding workshop and studio in North Hobart, Tasmania, Australia, and I'm going to do a bit of a demonstration of some of the assistive technology that I use to make things as a legally blind designer and maker of furniture and lights. So we're standing in front of what's a table saw, and I'm going to just show you one of the sort of foundation things that designer makers often want to be able to do is cut things accurately. So to start with, I'll show you some of the stuff that I've made here, and then what I want to measure, and using the way I used to do it, and then the way I now can do it, because I've just recently had some new technology developed. So this here is a little miniature cabinet. I did a lot of the sort of joins with all these little bits and pieces in here with little things called dominoes, which are like little floating tenons. And so in between each little support, there's a few of these sort of holding them together. And there's a lot of sort of making of things that woodworkers call jigs, and they can then determine where you put those holes or how you cut things in certain ways. So this is a talking tape measure. This is probably one of the more central tools in the workshop. It's quite handy for being able to measure things to sort of accuracy of 1 or 2 millimeters. But it's it sort of has this little system that means I can then measure whatever you can generally sort of find in the workshop, but it's also it's particularly handy for a lot of things, but in terms of accurate cuts, it has a few limitations. So for example, if my calipers died in the past, what I had to do was often put this into
spirit measurements without the case measurements with the case.
The measurement with the case option. I then measure point to point,
72 millimeters, including case.
and that says 172 millimeters, which accuracy to a millimeter with things like fitting drawers is just not really good enough. So this is a piece that I've had cut up previously, bit over the original size that I was measured with the tape measure, sort of allowing for that extra millimeter of tolerance I was talking about. And this is the way I used to do things before I had a full digital readout talking system. So I then get the thing that is slightly oversized and just basically keep on taking off in really small increments the off the edges, so that I could get it down to the precise amount that the actual draw was, and so in terms of getting it so that it can run smoothly on either side of those runners. So that was the way I used to do it. Then there was another little device that I've come across through different sort of blind woodworking email lists, and that's called a click rule. I won't show you the full capacity of how this thing works, because it's despite it looking really simple, it's actually a really handy little piece of equipment, and it's also quite versatile in what you can use it for. So it's really good for point-to-point measuring. So what we've done there is set it, and this is also good for going a bit oversized and then putting it on the table saw and line it up against the tooth of the blade. So that is also relatively accurate, but as you can see, there's a little bit of having to make sure it stays square as you're doing things. So this new system I've got integrates something I've had for a while called talking calipers, talking vernier gauges, and then I've got a new digital readout system that can measure from the point to point measuring, basically, in terms of getting from one side of the blade to the side of the fence which you're actually cutting from. And that's got quite a bit of accuracy to it, and I've got that now set up on the table saw and thickness planer, and it's quite important to be able to have those sorts of accuracies, especially for fine furniture. So I'll turn this on.
167.40 millimeters.
It's always great to sort of show the problems of these things, because despite having the technology, it can sometimes be temperamental. There we are. So I had to zero that a few times. This thing's called a voice man.
0.00 millimeters.
I should probably recross that out and call it a voice person. But
0.00 millimeters.
these calipers can now transfer what's here on the display and read it out in an accessible manner, so I can understand what's going on.
172.40 millimeters.
I use this piece of technology that I've had for a bit, and I will be able to, means I can measure with this the thing I want to cut to. So for example, a set of drawers, and measure the internals to be able to fit the drawer fronts. Then I can then transpose that measurement over to the digital readout, which has been fitted to the table saw. Table saw is quite exciting, really. It's got a linear track, an optical linear track, which has transfers into a digital readout, and then that digital readout has a cord which transfers the signal from a proprietary signal to a USB signal, and that signal then goes into a thing called a Raspberry Pi, and that's had some custom coding done by a local fellow called Dennis, and the tracks and things have been fitted by a fellow furniture designer maker, Stuart. And that system takes a few things that are off the shelf from a company called ProScale, but then it grabs a bunch of other bits and pieces, and it's got some custom hardware that's had to be especially developed, hardware and software that's especially been developed to create what is accessible for the average sighted person. When they look at like a ruler or a digital readout, they can just look at it. For me, for the last 13 years, I've had to sort of do a lot more guessing and checking like the previous systems.
172.43 millimeters.
About 172.4. One thing that's quite important when you're going anywhere near the blade, if you, for any practitioner, but especially for someone that can't see the blade, is just make sure the blade's off by hitting it with a piece of wood, not touching it with a piece of wood, and making sure that the e-stop is on, so that you've got no chance of it going on while you're adjusting things near the blade. What I've got here is the digital readout, which I'll turn on, and the Raspberry Pi is already on. It takes a little bit of time to boot up, so I'll press the data out. 177.5. I think I need to get to 172.4.
169.49. 171.97. 172.42.
Yeah. Just do it up and make sure it doesn't move.
172.38.
Basically 172.4. Okay, so now we've got that that measurement. We're gonna do the cut. So that's one fit to that drawer now. So that's the demonstrates how I can get accurate measurements with the devices I have on hand.